Voyager 1, the world's most distant spacecraft, is sending useful data back to Earth, a remarkable turn of events given its 10-year journey into space. Voyager 1, which traveled farther than any other man-made object, made discoveries that did not meet expectations. This surprising discovery has excited the head of NASA and raised questions about what lies beyond our understanding of the universe. The spacecraft will continue past Neptune and leave our solar system to become an interstellar explorer destined to roam the planet forever. For nearly 50 years, the Voyager missions have provided some of the first and most spectacular views of the wonders of the solar system. Surprisingly, these missions did not take long to build. In the 1970s, Michael Minovich came up with the idea that a spacecraft could use the speed of a planet to reach the inner solar system. Originally planned to last only 5 years, Voyager's performance has far exceeded these expectations. Voyager 1 and Voyager 2 launched a few weeks apart in the summer of 1977, were the first to explore Jupiter and Saturn. They achieved this goal by successfully studying these wind giants, but they didn't stop there. Voyager 2 made the first close-up observations of Uranus in 1986 and Neptune in 1989. These flybys of the 4 planets were given the mission name Voyager's Grand Tour. Instead of ending its mission, the humble Voyager took on a bigger goal, exploring deep space. Now, 46 years later, Voyager 1 and Voyager 2 are still traveling and collecting valuable scientific information from space. In a 2013 announcement, NASA announced that Voyager 1 had officially entered interstellar space, the region between the stars, beyond the influence of the sun's particles and magnetic field. It's like moving from a busy solar system to a quiet desert full of stars. Voyager history continued in 2018, when Voyager 2 once again entered this vast region 17.7 billion kilometers from the sun. In particular, Voyagers 1 and 2 were the only spacecraft to enter interstellar space and began investigating the role of the interstellar medium in the sun's solar atmosphere. That NASA's Voyager 1 and 2 spacecraft are the first source of information about the heliosphere, the shield that surrounds our solar system. The heliosphere is formed and controlled by the solar wind, a constant stream of charged particles emitted from the sun. Voyager 1 and 2 serve as satellite reporters, providing valuable insights into this celestial shield. The data correlates to the heliopause, the active region of our solar system, and shows the transition from the solar wind to the vastness of interstellar space. NASA's Voyager spacecraft has provided new information about interstellar space. The most surprising thing is that the 5 items of the 2 spacecraft are doing well as of 2019, which is not expected. NASA experts are unsure whether the Voyagers will continue to operate in temperatures that would freeze other spacecraft, a mystery that deepens the legacy of these space pioneers. The outer reaches of the solar system surprise astronomers with unexpected phenomena. The heliopause, which acts as a boundary between the sun's influence and interstellar space, is not constant. Instead, they move and create strange angles that surprise and confuse scientists. This idea of the heliopause cycle is not new. Over the past 10 years, scientists using data from Voyager 1, Voyager 2, and NASA's Boundary Explorer interstellar satellite have seen the heliopause appear to be changing. These spacecraft are important because they provide accurate measurements of these regions of the world, even if they are at a specific point in time and space. Dr. Eric J. He saw how IBEX, another satellite, added important data to help scientists better predict the movements of the heliopause. Recent studies have challenged what we thought. In 2014, IBEX observed unusual brightness of energetic particles, indicating some deviations in the heliopause. However, these variables were not included in our current sample, which is more like an unexpected twist in a story. In addition, after studying the data from Voyager 1 and Voyager 2, researchers noticed significant changes in the location of the heliopause for a short time. This motion may explain why 2 probes reached interstellar space in 2012 and 2018, with a large gap in between. These unexpected behaviors are not only confusing, they contradict what we thought we knew about the heliopause. In a new paper in Nature Astronomy, scientists refer to these differences as exciting, meaning they are misunderstandings and can be debated in the scientific community. But don't worry, the search for answers continues. New scientists are eager to learn more about NASA's upcoming Interstellar Mapping and Acceleration Probe, scheduled for launch in 2025. This advanced satellite promises to reveal more mysteries about the outer reaches of our solar system. Until then, we can only marvel at the mysteries that await beyond the heliopause. In May 2023, Voyager 1 witnessed an unusual event during its normal mission. The part of the spacecraft responsible for controlling the large-scale antenna, known as the Attitude Control and Communication System, ACS, began transmitting ambiguous data. Instead of previous updates on the health and status of the spacecraft, Voyager 1 appears to be having trouble communicating properly, much like a human would have difficulty speaking fluently due to a form of electronic aphasia. From our perspective of Earth, Voyager 1 appears to have suffered from electromagnetic interference. As NASA explained at the time, the data returned was either random or inaccurate. Interestingly, despite these mixed reports, Voyager 1 appears to be doing well. The radio signal remained strong and stable, indicating that the antenna was still pointing at the ground, contrary to what the ACS had indicated. Voyager 1 science instruments were added to space for no reason, with no knowledge of the ACS failure. Additionally, the spacecraft's fault protection system, designed to respond to malfunctions by putting the spacecraft into safe mode, was not activated by the crash. Fortunately, NASA quickly identified the problem. ACS seems to be using a computer that has been out of business for a long time. The solution is simple, a command to move to a working computer to transfer data. However, the mystery remained as to why the ACS did it differently in the first place. NASA suspects it was caused by a command error from another computer on board. Although this incident did not pose a serious threat to the safety of Voyager 1, NASA is actively investigating to prevent similar incidents in the future. For more than a decade, Voyager 1 has been exploring interstellar space beyond the Sun's protective magnetic field. This magnetic shield, similar to the Earth's magnetic field, protects the spacecraft from cosmic rays and other cosmic radiation and acts as a missile. When it comes to technology, just as computers on Earth face challenges from energetic particles and solar radiation, Voyager 1's computers on the upper surface face the challenges of the world. Sometimes, energetic particles can interact with computer chips, leading to small memory errors that build up over time. Susan Dodd, the project manager in charge of Voyager 1 and 2, has a global perspective on these challenges. He says that encountering these mysteries is part of the process at this stage of Voyager's mission. These spacecraft have been on a remarkable journey for almost 50 years beyond the mission lifetime. It is worth noting that they are traveling through interstellar space, an environment filled with high levels of radiation, a region that has not yet been explored by spacecraft. Almost 50 years have passed since the voyages of Voyager 1 and Voyager 2. They traveled far, explored unknown territories, and discovered new knowledge. Now venturing into interstellar space, these legendary spacecraft have a unique challenge. Their 1970s computer systems run on just 70 kilobytes of memory. Yes, that's right, only 70 kilobytes. Despite these technical limitations, NASA has continued the work of these distant probes. Imagine the ability to send software updates across global distances to keep things running. This is like giving cosmic IT support. As a result, in the great darkness of space, billions of miles away from Earth, the Voyager probes have crossed incredible thresholds, giving humans a deeper view of things. Loss of the solar system. Let us pause to salute these space pioneers, the twin Voyager probes. They are already bidding farewell to our solar system and moving endlessly among the stars. The size and weight of each monitor can be compared to a small car. It's like the old stories about space exploration that hold the state of technology of the 1970s. It's true that their computer systems were less powerful than today's digital clocks, and their analog television cameras were not as old as modern cameras, but they left an indelible mark on every celestial body they encountered. Thanks to the Voyager spacecraft, we learned some interesting facts about Jupiter. This is no easy giant. A giant planet, hundreds of violent storms, a bright aurora in the northern hemisphere, and 3 rings that are harder than a braid. Also, Saturn surprised us. Rings, thought to be small and simple, thousands of rings and weaving structures that experts thought were impossible. Most surprising is the discovery of active volcanoes that were previously thought to be unique to Earth. These volcanoes were found on Jupiter's moon Io and, surprisingly, on Neptune's moon Triton.